Hey there, folks. In this video, I want you to turn to the page in your packet that has using formulas at the top. Now, how we're going to be using formulas, typically they're going to be our area or volume or length of the sides of a triangle type formulas. And what we're going to use those for is we're going to be changing things around. We're not going to be using them in the direct way that they give us. So if they're asking us to find area, they're not going to give us the length and the width. Okay, they're going to be changing things up on us. So that's why we're doing this. And here is a formal reason. Okay, we could solve for any variable in terms of the other variables. Okay, and here's why. Okay, if some of the numbers are staying the same and we're going to be constantly solving and using the same operations, we don't want to have to do that over and over again. So, because we would be repeatedly performing that computation, we do it once, okay, and that helps us find that last value, okay. So we use the same constant values and only one number changes. That's going to help us find the missing one. So now the thing to remember is when we're doing this, remember we're using inverse operations. We're doing reverse PEMDAS. Okay? So you get rid of parentheses initially by distributing if you need to, and then you combine like terms. But that leaves everything else still to be done. So we undo adding and subtracting. Then we undo multiplying and dividing. Okay, but that leaves us with exponents. So we have to think about how are we going to undo an exponent. Well, if something is x squared, okay, we have to think about how do I undo squaring? Okay, or how do I undo cubing, something to the third power? Well, you've already worked with it, okay, in past courses. Okay, to undo a square, you square root. So the square and the square root cancel each other out, leaving just what is inside. Okay? And that would also work for a cubed root. Remember that a cubed root, okay, might look like this. Okay? Well, that's a cube. But the cubed root looks like this. It has the little 3 in the little corner here. They call that the index. Okay? So that would cancel. That would leave us with just x. Okay. So guys, let's turn the page and do the first one together. So I have, in this situation, a cereal company is designing a new box, and they want to consider several possible box sizes. They know the box should be 12 inches tall to fit on the shelves. They know they want the box to hold 400 cubic inches of cereal. They're asking us to calculate the width of the box using the possible different lengths. Okay, so in order to find the different lengths, okay, they remind us that the formula for volume is length times width times height. Okay, so we need to go back through and look at what parts of this formula do they already tell us numbers for. So they say they know the box should be 12 inches tall to fit on the shelves. That's going to be our height. Now, the next number that they tell us is the box shall hold 400 inches cubed of cereal. That's the volume. So the first thing I'm going to do is I'm going to rewrite this formula using these numbers. So 400 equals, I don't know the length, so I'm going to use a cursive L because my lowercase l's look like ones. They don't tell me anything about the width, but they do tell me what the height is. Remember, they said the height is going to be 12 inches. Okay. Now, they want us to solve for L. Okay, I'll solve for L. Okay, I don't see a plus or a minus sign. Okay, so don't have to worry about undoing that. So I have to undo multiplying and dividing. So I'm getting L by itself. L is being multiplied by W and 12. So I'm going to divide by W and 12. Now remember, the order does not necessarily matter when we multiply. So the 12s cancel, the W's cancel, and we find that L equals 400 divided by 12W. So that is our formula. Okay. L equals 400 divided by 12W. So now, one of the things that they're going to ask us to do is plug in these numbers. Well, this is something that consultation firms get asked to do all the time. A larger company comes to them and says, we have this problem. Could you solve this problem for us? And that's what they get paid to do. They do one part of the process. They go back and they make a recommendation. So that's what we're doing. We're doing the legwork. We're doing the computations so that someone else can go back and give a presentation. So I'm going to use that down here. L equals 400 divided by 12W. Now, in the first case, they want the W to be 2. Now, you have to remember, in order for this to work in the calculator, you have to use parentheses. So I happen to have a calculator handy that I can display. So I'm going to type in 400 divided by, open the parentheses, 12 times 2, and close my parentheses. I hit enter, and it tells me it's 12.67, but they ask us to round to the nearest tenth of an inch. So that's what I'm going to do. 0.66 rounds to 0.7. Okay, now they want me to plug in 3. Okay, so I'm going to put 3 in place of the 2. Now, so I'm just going to type that in. 400 divided by, parentheses, 12 times 3. I get 11.1 repeating. So that's just 11.1. Now I'm going to do the same thing, but with the 4. So 400 divided by, parentheses, 12 times 4. Enter. And it tells me that it's 8.3 repeating. So that's just 8.3. Lastly, I'm going to do it again for 5. So 400 divided by, parentheses, 12 times 5. And it gives me 6.6 repeating, so that rounds to 6.7. Okay. Now, if I had started with the original formula each time, and I had to solve it each time, that would have taken even more room, as well as time, too. Since I had already gotten L by itself, I only had to plug it in each time, and I was able to find my solution. Okay. The next several questions are very similar. Do remember, be careful. Like down here, number 2, to undo a fraction, okay, that's being multiplied, remember you have to multiply by the reciprocal. Okay. If you have any questions, go ahead, feel free to ask when you get into class, or if you're watching this and there's another teacher coming in, feel free to ask them once they come in. Okay. Good luck.